One thing that's useful is pooling. So this is a layer in a convolutional neural network that will go ahead and reduce the spatial dimensions. So we've got a 6 by 6. And this can be much bigger, but we're just giving an example. So we've got a 6 by 6, and we want to shrink this down into a 3 by 3. So the simplest thing we do is we just said, well, we'll take every 2 by 2 square here and turn that into 1 square here. So we'll take this square, okay, those 4, and send those to here. And what we want to do basically is summarize these. I'm going to call them pixels, but these values, okay? If it's an incoming image, of course, it's pixels. If not, it's just values spatially. So we can do one of two things. We can either take the max, or we can take the average. So for example, if my values are 32, 1, 7, -3, let's say, then if I want to do the max, that would just be 32. Or if I do an average, that would be 32, 39, 40, 37, so that's 12 point something. And so what it tells us basically is we have got in this area, so if we're taking the max, we're saying this feature has occurred in this 2 by 2 grid. Okay? And so we are capturing that fact by using the max. The average is more often used for something rather than that you might have something more like average, like grassy area or something like that, some kind of largish area, as opposed to a distinct feature. And we're not making these up, remember. This is just being determined by the neural network. Okay, so, but there is a judgment call you have to make of, do I want to do max pooling or do I want to do average pooling as I'm doing this shrinking? And 2 by 2 is what's very often used. If we have an input, so let's say we have a 6 by 6 by 12 input, knows this is not to scale, and we want to feed that through max pooling. So we do a 2 by 2 max pool. Well, what we're going to actually do is do the max pool independently for each layer. So we're going to take the first 6 by 6 by 1 plane, and then we're going to go through and do a total of, what's it going to be, 9 different max pool operations. Okay, so that'll give us the first 3 by 3 by 1. Then we do the next one, and the next one, and the next one, and the next one, and so on. And it kind of makes sense, right? So in a convolution, we're trying to mix together information from the various layers in the input. Here, we're not trying to mix together. All we're really trying to do is just shrink in the width and the height while summarizing what is happening in each feature map. Okay? So we would go through and create a 3 by 3 by 1 and another 3 by 3 by 1 until we had all of the 3 by 3 by 12. If we couldn't decide whether we wanted an average pool or a max pool, we could actually go ahead and just do both. We could say, we'll go ahead and do 12 maxes, and then let's go ahead and add on another 12 averages. That's certainly possible. When you're specifying a pooling layer, your specifications are really, is it a max, is it an average, and what is the size of it? Is it 2 by 2? Is it something larger? Virtually all the time, the stride is going to be equal to the size of this, let's call it a kernel, this pooling kernel. Okay? So if it's 2 by 2, then your stride is also going to be 2. So rarely do you have overlap in your pooling. Commonly, when you're specifying a pooling layer, you're going to go ahead and specify for the pooling layer, you're going to specify the height and the width, and you're going to specify average or max. The height and the width then is going to basically take in some incoming height and width. Let's say we have 30 by 30. And then if we have 2 by 2 pooling, that'll take this down to 15 by 15 by however deep it is. Sometimes you may be interested not in specifying exactly how big these pooling kernels are, but instead you want to be specifying the output size. So there is a different kind of a pooling called an adaptive pooling. And here you specify again max or average, but instead of specifying the kernel height and width, that is how big the pool is, you instead specify the output height and width. So if we're using a 2 by 2 regular pool here, alternatively, we could choose to do a 15 by 15 adaptive pool. These would do the same thing. This one indirectly is saying you're ending up with a 15 by 15, okay? That is assuming the input is 30 by 30. It's going to give you a 15 by 15. The key is the adaptive pool actually will work with whatever size you give it. So if you come in with a 30 by 30 and you do a 15 by 15 adaptive pool, you're going to get a 15 by 15 output. How? It's going to do the same 2 by 2s that this one would do. If, on the other hand, you have an input that is a different size, and this is definitely not to scale, my apologies, but let's say we have a 22 by 22 by K. Then, if we feed this into our adaptive pool, this would still end up with a 15 by 15, right? If we ran this through a 2 by 2 pool, non-adaptive, it'd turn into 11 by 11. But we may know in our network, we actually want to end up with 15 by 15, no matter what's coming in, whether it's a 30 by 30 or a 22 by 22. And so therefore the 15 by 15 adaptive pool is going to do it. How is this going to work, given you can't divide 22 into 15 evenly? Well, if it does divide evenly, it does just what it would normally do. If it doesn't divide evenly, it's going to actually make pools of different size. So we're going to have some pools of size 2 along here and some pools of size 1. So presumably 7 pools of size 2, horizontally and vertically, and then the remaining, yeah, because that'll use up what, 14? And we'll left 8 remaining 1 by 1s. So the adaptive pool will do the right thing based on this input. How could we ever have different inputs? Well, you can imagine if you have in a convolutional neural network where you have incoming images, right? You may want to be able to deal with images of various sizes. And so as long as all of the images in your batch are the same size, you could go ahead and feed it through your convolutional neural network. And then once it got to the 15 by 15 adaptive pool, it would just go down to 15 by 15, whether it was large or whether it was smaller. That's adaptive pooling.